Hi guys, Shouvik here. Welcome back to YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes. So today we have these problems like domino and tromino tiling. Yeah. So first we will understand the problem statement. Although this problem is tagged as a medium, but I personally feels like understanding the problems is quite challenging because the way they have written the English. So I think that is more than kind of a medium. Maybe like a easy versions of hard problems. But yeah, it is bound to be a more than a medium problems. Yeah. So they have given us two types of tiles. One is a 2x1 that is of domino shape. So here you can see. So this is a domino shape tile and a tromino shape. On tromino that is kind of an L shape tiles they have given. And what the opportunity they have given us, they have allowed us to rotate these shapes. So we can rotate these shapes to make it on other form also. Right. Now they have given an integer n and we have to return the number of ways to tile a 2x n board. So we know, right? We have to create a 2 row and n columns fully filled board with the infinite supply of domino and infinite supply of tromino. So how many ways we can fill that 2x n board, right? And since the answer may be very large, we can return it in modulo of 10 raised to the power 9 plus 7s that we have to do. Yeah, so here you can see in a tiling every square must be covered by a tile. So that is bound to be happen. In a tilings every square must be covered by tile. So that I already told. So the 2x n board that you are making, every cell should be covered by tiles. Two tilings are different if and only if there are two 4-directionally adjacent cells on the board such that exactly one of the tilings has both squares occupied by a tiles. So that actually this lines is kind of a like very vague kind of English they have written, but yeah, like on high levels, if you put a like L-shaped tromino, then you can put a domino there. So if I can give you an example, so here you can see this is blue, yellow, green. So that is one example. So that is of you have put domino in verticals. So there should be like only one configurations of vertical 3 dominoes, you can say. So you can't do something like this. If I can go to my OneNote, by the way, on these problems we will heavily do whiteboardings of OneNote. Yes, so what I am basically stating that if you are going to, what happens, so if you are going to make a domino combination, combinations of two verticals, so that is, let's suppose the grid that we are considering, that is of 2x n. If n is given us as 3, if n is given us as 3, so let's suppose that is of color yellow, that is of, let's suppose, green, and that is, let's suppose, of color blue. So you can't do like there is, you can't say there is another configurations of same with 3 dominoes verticals, one with this, another one is this, another one is kind of this. So no, that is not valid. So you can create the arrangement of, if you are creating 3 domino verticals, then there should be at least one. There should be bound to be one. There should be bound to be one configurations. Like here you can see this is like filled by 1 vertical domino, 2 horizontal domino. Here 3 vertical dominoes. Here 2 verticals up down and 2 verticals. 2 horizontal and then 1 vertical. 2 horizontal up down and 1 vertical. 2 tromino in like different shapes. One forming like reversal, this one forming up reversal, one forming down reversal. Here simple L, up reversal, up reverse backward L, something like this. So all the configurations are unique. All the configurations are unique. So here you can see for n equals to 3, these 5 configurations you can achieve. For n equals to 1, I guess there should be one. There should be one. For n equals to 1, so we only have this like verticals one. Only one configurations of vertical, right? Yes, guys. So this is the problems they have stated, and they have given the constant of n equals to 1000. So just by looking very naked eyes to these problems, what actually coming to your brain? So now go to the intuitions building part. So we know we have some insight domino, insight like tilings, tilings. So this can be grow to n, and there are 2 rows, 0 and 1. So So what actually coming to our brain? If let's suppose we are at any arbitrary ith index which is lying in range of 0 to n minus 1, 0 to n minus 1, what actually coming to our brain? If we are at arbitrary ith index, we are standing at arbitrary ith index. So we definitely have choices, right? We definitely have choices, right? Because let's suppose this cell is empty, and our down is also empty, so the ith index that we are stating, let's suppose both are empty, both the cells are empty, then what all the domino or trominos we can put to make these cells, to make the current ith cells to be filled, to make the current ith cells to be fixed. So we definitely have choices. So if I can cut these chunks, if I can cut these ith chunks from here, and if I am going to create, if I can try to basically set some domino and tromino on it, if I am trying to set some domino and tromino to it, to make these particular single chunks to be filled, to basically make this particular single ith chunks to be filled. So what are the combinations? One, I can put a vertical domino, a single vertical domino, a single vertical domino, right? Second, I can put so for the next go, that is of I plus 1th index, so that is pointing to I plus 1th index, both are empty, that has filled by a, that is of ith index, that is of I plus 1th index. So ith index is completely going to be filled by this, and I plus 1, for I plus 1 both are free. Again top and bottom, top and bottom, both are free, right? Both are free. That is one configuration. Now if I can draw the second configurations. Now what we can do, we definitely have to fill the ith cells. Okay, now on that times we put a single vertical domino. Now in these times I am trying to put two horizontal domino. So then so that is one. Second one is this. So my ith cells are going to be occupied, but on this case my I plus 1th cells also going to be occupied. So here up and down of I plus 1 both occupied, right? So I am writing the cases. What is the opportunity if I can apply, if my both up and down of the ith cell is empty, right? So first one is this, second, that is the first one, that is the first configurations we can do, that is the second configurations we can do. Do we have more configurations? Yes. So what all those? So that is the third configurations. What we can do now, so if I can put a L-shaped tromino, how? Like this way, which I am highlighting. If I can put a L-shaped tromino, yes, I can. So on that case, this is going to occupy this entire block. So ith cell is filled, that we have to do, and my I plus 1th cell is downfill, only downfill, up is empty. So on third configurations, my up empty, and down filled, right, for I plus 1, because ith we have to fill, because on the problems they have written, right, for intermediary cells there is no opportunity to make any of the cells to be empty, and we are finding for to basically make our tilings to be complete. That is never going to be happen. We fill I, and for I plus 1, what is the opportunity we are going to make for I plus 1, right? So that is third configurations. Do we have more? Yes. We have one more. So what next then? So on fourth configurations, okay, that there is a space issue. So on fourth configurations, maybe I can put my ith cells to be filled with a tromino, but kind of a different. So I can put it something like this, which I am highlighting, right? So then this is going to be occupied some these fashions. So then on that case, my ith cells is going to be completely filled, and for I plus 1, up filled, down is empty, down is empty, right? Do we have more? Do we have more? I guess no. I'm pretty sure there is no further configurations that you can achieve. So with Domino Tromino you can try, but there is no configurations you can achieve. There is no configurations you can achieve. For ith cells to be completely filled, make sure ith cells to be completely filled, and it should not go like on up. So this should be like in dot. If I can draw, it should be block with in our two-dimensional 2n grid. So that is our of size 2 and that is of size n. So that should be blocked. Like you can't put like it should go out of your 2 row. It should go out of your 2 row. No, that is not valid. That is not valid. So you can try. So these 4 configurations you can achieve when you have both your up and down empty for the ith cell. For ith cells. Now we saw some transitions where for our I+1 up is available. So here you can see up available, down block. And one example where and one example is down available, up block. So let's write for that test cases. Let's write what is the configurations we can achieve for those. So now again, if we are standing when my up is, let's suppose, empty, but my down is coming as block, right? For your ith index that is the initial configurations. That is the initial configurations, because we saw, right, if we put a L-shaped block, then your down can be blocked, right? Because something like this, maybe on the last configurations when you considered your I-1, when your I at last place, you put a Tromino, something like this, which basically block this. So when you are at ith configurations, you base for every I you have to fully fill this, so there is an empty space. Now what is the way you can fill it? So I can again redraw, because for that L configurations I just want to see how your I is going to be up empty, down fill. So that I saw you. So now let's consider this only. What happens? Why it is not writing? If we want to make myself see dust. So if I can try, no, still not working. It's working on top sections, but it's not working on the bottom sections. I don't know why it is happening, something like this. Maybe I can use the right space then. Yeah, so I can redraw here. So let's suppose I have there may be some issue on the down or where I am writing it. Yeah, so if I am at ith index, we obviously have to see what is the I+1 configurations if we are standing at ith index. So for every time I am writing the I+1 we will calculate. So for ith index, let's suppose your bottom is filled but your up is empty, your down is filled but your up is empty. So what all the configurations similarly we can try to draw. Can I put a domino above vertically? No. If I can put a domino, it can grow to something like this, which is making it out of boundary. So domino vertical is not possible. Can I put a domino horizontal? Yes, I can. So on first configurations, I am putting a domino horizontal. Yes. So on that case, what is going to be happen? This is already filled, and this cells, this is going to be also filled. So I filled, and for I+1, what is for my next call then? For next call, it is going to fill. It is going to make up filled, down. My down is going to be empty. Down is going to be empty for my next call. Yes, definitely. Do we have other configurations? Yes. Another mode. Can I put like vertical, like a Tromino here, kind of this? Can I put a Tromino here, which I am highlighting? You guys, I guess you are following. Yes, obviously. So on that case, these cells are already blocked, and we put a Tromino on this entire block, the block that I am highlighting. So we put a Tromino here, right? So on that case, your I cell and your I+1, what is the then transition for I+1? Up and down. Tell me guys, both blocked, right? Right? Now similarly you can try for the down ones. Maybe I can just draw it. Hopefully it should work here. I'm not sure why it is not working. Here it is not working. Okay, it is not allowed to draw down further. Not sure why. So maybe I can continue on right itself. Yeah, Yeah, so now what all the configurations for? So that we have discussed for which configurations we have discussed, that is for up empty, down filled. Now let's discuss on down empty, up blocked, down empty, up blocked. I think that is also going to be very straightforward. We should have, that is our I, we should have only two configurations. Similarly, we will do the reverse. We will put a domino horizontal in down box, so that is already filled, and we are putting a vertical domino. So our I and I plus 1. So for I plus 1, what is the configurations? What is the configuration? Tell me guys. Our up empty, down blocked, right? And what is the second configurations we can achieve? Tell me guys, tell me, you should have to tell it. So I can put a Tromino, which I am highlighting. I can put a Tromino, definitely. So I can put a Tromino here. So on that case, my up and down both blocked, right? Both blocked. Yes, obviously. Now the very last case. When my, so if I am at ith index, if my both up and down are already filled, are already filled, do we have any opportunity to fill here? No, we are good, because we are only trying to fill our both up and downs. If up and downs is not good, then only we are finding the combinations. So here nothing have to do. We will go to the same configurations with for I, that is the configurations only, and for I plus 1 only 1. So for I plus 1 we will make the calls up and down, both empty, right? Both empty. Definitely we can make the calls, right? So that all the transitions we just have to write in our pseudocode or the recursive code, and post that we will try to optimize with the dynamic programming. Yes, so now I think we are good. We can try to start with writing this all the whiteboardings that we have done, all the cases that we have written, we just need to write, kind of have to give it a code versions. We have to write it. We just have to write a code versions for it, right? So I'm not sure why it is not working on the down. So maybe I can use the right space only. Yes. So for our initial call, where is my cursor? So I definitely have a functions. I definitely have a recursive functions which will take the current index, which index I am landing, which index, that is the ith index for which we are doing the calculations. And we have two variables. We definitely need two variables. One is basically stating me can put up, am I able to put, allowed to put on up, and allowed to put on down. So these two variables are booleans, true false only. Have I the liability to put on up and put on down? So that is exactly that we are seeing on the last intuitions building. So we have that boolean flags. Based on that, we will write our cases for all the 4 cases that we have discussed, right? So let's first write the cases one by one, then we can write the base cases of the recursion. First we can just give the code versions of the logic that we have, whiteboardings that we have done. So if my up and down, both are empty, so both are true means both are empty. So what is the next functions called? So I have to return the number of distinct ways. So I can initialize my count variables to be 0. So what is the for ith index? How many ways I can find? So I have initialized my count variables to be 0, and I am finding. If my up and down both are empty, how many functions call we will make? One is I will go to my index plus 1 for sure, and I can make. If you guys forget, that's the reason I am just again going to iterate what all the 4 cases. First case is for my I plus 1, I have just put a vertical domino, and I'm making my both the I plus 1 as cells free, right? So where we are? Yes. So on my next, my both I plus 1, that is of my both bottom and top, are going to be empty if I put a vertical domino. Second case, if I put two horizontal dominoes, kind of this, 2 horizontal dominoes. So this block is also going to be filled, and this block is also going to be filled. So for my next functions call, I am definitely going to be index plus 1 for sure, and both are going to be false. For sure. If I put two horizontal dominoes in up and down fashions, right? What next? What next? If I put a Tromino, in L-shaped way, something like this, that I am highlighting, this entire block, right? So my next index plus 1 up is empty, this one is empty, but down is altogether filled. So my next function's call is going to be happen to be index plus 1, my up is going to be empty, so up is true, I am able to put, and my down is going to be false. What next? What is the next configurations that we have discussed? We have put a this kind of L, so on that case this up is going to be filled and down is empty, So on my next function's call, count plus equals to helper of, I am making the next function's call index plus 1 to be up is blocked, false, down is empty. These 4 cases I have just given it to a code versions. What we just draw. We have just given it a code versions, right? That is the first case. What's the next case? Elif. So if both are not true. So let's suppose I have the liberty to put on only up. Then what is the fundamentals? What we can do? So only up is empty. So if I can go here, so only up is empty. So on I can put this vertical domino. Then on that case I can put a horizontal domino. Then on that case my next call up is going to be filled but down is empty, right? So up is false, down is true. So I'm making an helper call for sure. If my up is empty, index plus 1, my up is going to be filled by putting a horizontal domino, and my down is empty. Yes. What next? Count plus equals to helper of what next? Another I think we discussed, right? Tell me guys, tell me. Another ones that we can do, I can put a Tromino here, kind of this that I am highlighting. Or if I can draw it, I can put a Tromino this. So that is my Tromino, that is my the reverse gun shift Tromino. This is my Tromino, and this is already filled, and that is the Tromino that I have put, and my both next I plus 1 is going to be false. Both are false. So for next calls, both are false. So now I can just quickly write the only I have the opportunity to put on down to my down. If my down is empty, that is just of the reverse of it. So, or not a reverse, just of like kind of a like mirror image of the only up is available, only down is available, is just a mirror image kind of things of the up. So I'm not going to draw the diagrams that I have already done on last whiteboarding. You can just go to the reverse part of the video to see it. I'm just writing the cases directly. So if I have my down is available, so I can put a vertical domino. Then my next function's call, my up is available for sure, but my down is altogether blocked. So I am marking it false. And if I put a L Tromino, so if I am going to put an L, then I know what is going to be happen. Both are going to be blocked for index plus 1, right? That is the same cases for the up block. Both are going to be blocked. Both are false. Any other case? Charger. Give me 1 minute, guys. Yeah, how many? For charges. Okay, let's continue. I'm going to get the charger. Yes. So the next case is both my up and down is filled. So on that case, what is the opportunity I have? Tell me, guys. Tell me. Let me just put the charger first, na? Otherwise I again have to repeat the entire recording. Yes, so it's charging. Fine, yeah. So now if both are occupied, then we don't have to do anything. So we have already discussed if both are occupied, which cases, last case, this case, we have only one opportunity. We are going to make for our next index calls to have both are available, right? That is the case. So for this case, if both are like non-empty, up and downs we can put anywhere, then for our next functions call is going to be both are true. Yes, guys. So that actually all the transitions that we have discussed, we have given it to a code versions. If I can make the themes little bit smaller, I'm not sure why it is not happening. I can go from full to this if I can try now. Yes, I guess this page is hanged. Yeah, maybe I will give you that gist on the code itself. So that is the pseudocode we have it. So only the last things. What is the base case then, guys? What is the base case? All things we have covered. Only the last base case I just want to cover. So if I am moving to an I equals to my nth index, I equals to nth index. So that means I am out of bound. So what actually the points we have to consider to make what all the combinations we have made so far to be considered it valid. So my I minus 1. So my I minus 1 should be fulfilled. My I minus 1 should be fulfilled. Or specifically, can I say on the last test cases where I don't have the liberty to put on top and bottom, then for the next functions call. So I have the liberty to put both bottom and down, both top and downs, right? The very last test cases, the very last else, when we have discussed when both top and bottom is not allowing us to do anything. So on the next functions call, we are making both should be we have the liberty to put on both top and bottom. So my I minus 1 should be fulfilled, should be fully filled. So how I can check if my ith index, the index that I am standing, if my up and down, if on both up and downs I have the liberty to put, then can I return a true? Yes, can I return an 1? So that is the valid 1 combinations till now we have encountered. If that is not the case, we are going to return a 0. So we definitely know if for a particular index we are only going to have the liberty of both put up and downs, only going to be happen if my I minus 1 is fully filled. Yes, on that case only we are just making the next functions call to I plus 1 with having both up and downs to be true, right? Having like basically enabling the liberty to put both up and down. Yes guys, so that actually all the function transitions, I guess you guys are able to understand. I know it's explaining it's too hard, but I tried my best with all the diagrams that I actually did on pen and papers to figure out the most optimal solutions, and I tried to give the entire intuitions, the entire gist, so that the problem is going to sit on your node. If on future if you are going to face this kind of problems, you are on very good state to write all the transitions, all the recursive functions, next transitions calls on your own. Yes, now we can go to the code iterations, and after that just the one-liners you have to add to make it in dynamic programming that we all know. Yeah, I will explain that on code iterations. Yes, so first I have created a DP things you can neglect for now. First we will just go to the function call only. So I have making the functions call initially with helper calls with index 0, and for very first we have the liberty to put both on up and downs, So can apply up is true, can apply down is both true, and this is the base case that we have discussed. If we are at nth index, if on very last index, how we can sure that the very last index till very last index all are fulfilled? If the ith index is going to be both both up and down is true, because that is the only transitions we did when we are making both my up and downs to be true when the very I minus 1 we have fully filled it, right? So if that is so, if my both up and downs is empty for my nth index, the out of bound or the very last, like out of the grid index, so that means my last till now the last index that we inside the boundary we have fully covered. We are returning 1, and else we are returning 0. This DP part I will cover. This DP part I will cover, but I guess mostly who know DP they are going to understand it very easily. And I have initialized my count variables. Now that 4 cases, the first case is both empty. I am making the exact, I have written the exact same code here. So I am making the helper functions called to index plus 1 for sure, both empty. True, that means I have put a vertical domino, index plus 1, both false, that means two horizontal domino, up down. True, false, one Tromino L-shaped, false, true, one Tromino, reverse L-shaped, like this. Already discussed. Just go to the one note if you are not able to understand. I have written exact same code. Can apply up, false, true. Already discussed exact same things. And another one is false. Can apply down, true, false. And that is the last cases where this is already filled. Like we can't apply on down and up and downs. Can apply up and downs. Both are false. That means the ith index that we are considering is fully filled. So for the next functions call, we are going to make both true. So here you can see like both true is only going to be coming when the index that I am considering till now it is fully filled. So one function call which is giving to next calls to be fully true, and that is the next call. So this calls like ith index is fully filled, and here we are making the ith index fully filled by putting a vertical domino. So on both the cases we are making the I minus 1th fields. If I am considering this index to be ith index, then my I minus 1th field, when I am getting both apply like up apply, down apply, both I can apply. So we are getting both true only on that case when my very I minus 1th index on both top and bottoms is full. So only we saw, right, only this functions calls we are returning only these two functions call. This one is this and another one is this. We are only making both up and downs to be true. Yeah, now the DP part, that there is nothing on the DP part, and you can see like the modulo things. I have initialized my modulo to be 10 raised to the power 9 plus 7s. So that's the reasons, because they have already mentioned the answer can be very large. So you have to return it in 10 raised to the power 9 plus 7. So that's the reasons I took a modulo, and when I am going to store on the DP file, before storing, I am just going to do a modulo, and post that I am storing. Yeah, so now I guess you guys are already aware of how to make a recursive code. I am pretty sure you can see, right? Actually writing the recursive code is actually the main intuitions is behind to the recursive code, right? If you are able to write, who all have able to write the recursive code, DP is kind of like they have written like this kind of way. Yeah, so for DP we have to create a I have used a dictionary. You can use a 3-dimensional grid also you can create. But yeah, like you can use DP like dictionary, that is going to be like more easy way to implement. And who all are the changing parameters for my case? Index can grow as big as from 0 to n, and can apply up and can apply down. These are like two boolean variables. So before making any function calls, any logic executions, you just have to check in this particular key, for that particular key for which this function has invoked. Index can apply up, can apply down. If for this particular key do we have any entry to our DP? So if that is so, then return from your DP. So that means that particular thing is already pre-computed. That we are doing, that is actually the nerve of the DP. And before returning any functions call, just store it, whatever the calculations you have done for these functions, just store these things to your DP before returning. So we are doing so, and finally we are returning what count or whatever the value we have stored in. Yes guys, so that exactly how actually the DP works. See, yes guys, the problem is on implementation perspective is as simple as that. If you are able to write all the recursive code, all the pen and paper work, all the transitions correctly, then the recursive code is as simple as that, and making is DP is kind of these things. And if we can quickly discuss the time complexity for these particular problems. So what are all the changing parameters in our DP? Index, it can grow, it can like grow as big of n. So it is obviously going to grow as big of n, and inside that can apply up has only two state, true and false, can apply down as only two state, true and false. So 2 cross 2 into n. So that is of how much? Big of n cross 2 for can apply to true false, another 2 for can apply down true false. So that is kind of big of 4n. So that is the time complexity. And on space perspective, space is also, I have to say, big of 4n, because that is the DP key we are maintaining to store all of them. So that is the like I have to say, like the solutions that I am able to find out, that is the most optimal time and space complexity that I am able to find out. But there is also more auxiliary space you for the recursive functions call you can there is, so that you can tell explicitly to the interviewer there is some auxiliary stack space, auxiliary aux stack space. But yeah, like just mention explicitly to the interviewer, because we all know if you are able to make a recursive memorization, then that is going to be happen. But if I am going to be an interview, then I am fully satisfied with all the if you are able to write all the recursive transitions code with proper diagrams, and if you write this kind of modular code, then there is absolutely no chance you are going to be rejected if you are going to get this particular question on interview. And that's it's the most optimal time and space complexity that I am able to figure it out. And there is I read it on the discussion section, there is kind of a intuitions building, like maths based formulations based after writing few more n for I think 10 or 15 of n cases. You can people are basically doing the diagrams for n equals to 15, and after that there is some basically hints or kind of like strategy of all the ends they are following, and after that they are basically creating a formula. So for that, like, time complexity I think speak of it. But yeah, but on intuition's perspective, like building that formula of writing on that interview, like till for n equals to 15, n equals to 20. But there can be cases like for these particular problems, maybe n equals to 15 or n equals to 20 people are able to basically correlate or generate a formula for n equals whatever, a generate formula for a for a general n value. But maybe some problems where you are not able to generate a formula after like n equals to 50 altogether. But on interview, you are not going to write all n equals to 50 till, right? So for that, I personally feel that is the most beautiful, like diagrammatical way of you can just write all the transitions, and post that you can just convert it to your recursive versions, and you are going to get an S with proper time and space complexity. Yes, I personally feel these problems is more modular, more granular, more explainable, and more readables also. So on interview, please take a note, like the way that you can explain in more easy way, you can go for that one. Yes, guys. So that is the most optimal time and space complexity that I am able to achieve of, and explaining this particular problem is kind of on different level of difficulty. Yes, guys, and if you guys are able to understand till this point, I guess you guys are already doing so. Please do subscribe to our channel, and please share the videos to your friend circle who are also preparing for top product-based company and also brushing up their DSS skills. And please turn on the notification so that when we are going to live to our next video, you'll get the notification as soon as possible. So that's it, guys. That's it for today. Let's meet tomorrow with another video post. Then bye, guys. Bye.